Let's talk about complex numbers. Now it's a huge topic altogether, so this video is only about ironing out the basics and the properties on complex numbers. For more advanced components of this topic, you can head on to other videos in my channel. So the first part of topic is always wondering how this whole topic came about. Now we know in a secondary school level that x squared plus 1 is equal to 0 has no real roots. Right? We always say that there's no real roots if b squared minus 4ac is less than 0, the discriminant. Right? But in this case, we learned in complex numbers that in fact polynomials of degree n, so in this case it's 2, right? It always has 2 roots. So degree n has always n roots, right? There could be repeated roots, but let's not talk about repeated roots in this case. Right? For polynomial of degree n, it always has n roots. So for x squared is equal to negative 1, we have x is equal to plus or minus the square root of negative 1, which is equal to plus or minus I, right? Which is equal to I or negative I. So these are the two roots. X is equal to I, x is equal to negative I. And let me show you another example to justify my claim. So we have x squared minus 3x plus 9 is equal to 0. Alright, and now I'm going to plug in the quadratic formula. So that's negative b plus minus square root of b squared minus 4ac. Right, so in this case, discriminant is less than 0. So now we're going to solve for complex roots. So it's 3 plus or minus the square root of negative 25 over 2. And that's equal to 3 plus or minus, right, negative root of negative 1 times the root of 25 over 2. And you can see where I'm coming at, right? So it's 3 plus or minus I times 5, right, over 2. And this gives us two roots, which is 3 plus or minus, 3 plus or minus 5i over 2. I'm going to talk about the operations on complex numbers now. So for addition and subtraction, it behaves the same as you would for algebra. So for example, let's say with 3 plus x plus negative 1 minus 2x, for example, right, you would get 3 minus 1 plus x minus 2x. You would put all the real numbers on one side and all the x terms on another side. So this is equal to 2 minus x, for example. Right, so the same for complex numbers. If let's say you're 3 plus I plus negative 1 minus 2i, right, you know that I is a known constant, so x is an unknown constant in that case, but for I you know that's equal to root of negative 1. It's just that no one writes it in that way. We all leave it as the form I. Right, so you group all the terms together, you get 3 minus 1 plus I minus 2i, and that's equal to 2 minus I. And you realize that all the complex numbers are going to be expressed in the form of x plus iy, where x and y are real numbers. So this is the clearest format of the complex numbers, the most simplified format, So let's talk about multiplication and division. We know that I is equal to root of negative 1. I squared is just negative 1 itself. I to the 3 is negative of root of negative 1. And I to the 4 is equal to 1. Right, so what do we know about I to the power of, let's say, a really high power, 2019 for example, this year? We know that I to the 4 is equal to 1, and if you multiply it by I again, which is equal to I to the power of 5, you'll go back to I again. So in fact, this is equal to I to the power of 5, this is I to the power of 6, I to the power of 7, and I to the power of 8, right, and so on and so forth. So you realize that dividing the exponent by 4, right, the remainder is what you will need, the information you need to find the result. So for example, if the remainder is 2, then you know the value is going to be negative 1. Right, so let's divide 2019 by 4. We have 5 and we have 0, 4. Right, so 4 times 4, 16. Remainder is equal to 3. Right, if remainder is equal to 3, that means that I to the power of 2019 is equal to I to the power of something times 4 times I to the power of 3. Right, and of course, I to the power of 4 times anything is equal to 1 itself. Right, and I to the power of 3 is equal to negative of root of negative 1. Right, so therefore, the result is the negative of root of negative 1. Now for multiplication of, let's say 3 plus I and negative 1 minus 2i again. Right, the multiplication is the same as how you would for algebra, just that these values are now known, so they're going to combine. So you need to take the real part first. So 3 times negative 1 is equal to negative 3. I times negative of 2i, well, that's equal to negative 2i squared. And now let's take the complex parts, which is I times negative 1, which is minus I, and 3 times negative 2i, which is negative 6i. So for 4 terms, so there's 2 terms multiplied by 2 terms, you're sure to get 4 terms. But you realize that these will simplify. Negative 3 minus 2i squared. I squared is equal to negative 1, so that's plus 2. And minus I minus 6i is equal to negative of 7i. Right, then this is equal to negative 1 minus 7i. We realize that this is in the form of x plus iy once again, where x is equal to negative 1 and y is equal to negative 7. Now let's talk about division. Well, let's say we have 3 plus I over negative 1 minus 2i. Now how are you going to change it to the form of x plus iy? Right, so remember that for surds, let's say we have 1 minus root 3 over 1 plus root 3. To change the denominator to something rational, we need to multiply it by 1 minus root 3 over 1 minus root 3, right? In fact, all we need to do is to swap the sign of these two terms. And this, for this case, is exactly the same thing. You need to multiply it by something called its conjugate, which means that it's the same real component but different imaginary component in the opposite direction. Right? And you realize that magically the denominator becomes a real number. So this is the same thing as having a minus b times a plus b. Answer is a squared plus b squared. So that's a squared plus b squared. Sorry, a squared minus b squared. And this is equal to, now let's apply the multiplication at the top. We get negative 1 minus 7i at the top. And that's over square of negative 1, that's 1. And square of 2i, that's negative 4, right? So that's plus 4. And the final result that we get is negative 1 minus 7i over 5, right, which is equal to negative 1 over 5 minus 7 over 5i. And this, if you realize, is in the form of x plus iy once again. There are a few more terms to go through. Now let's say z is equal to x plus iy, where x and y are real numbers, and z is a complex number, so z is an element of this c over here. So this c represents all the complex numbers. The terms that we are going to talk about would be real component of z, represented by rez, imaginary component of z, which is imz, and the conjugate of z. So conjugate is basically an asterisk applied next to the complex number, and it's spelled like this. So conjugate. And so let's start with real part of z. The real part of z is nothing else but this part over here. So in this case, it's x. For example, if you have the real part of 1 minus 3i, the answer is going to be 1. And for the imaginary part of z is equal to y, if you haven't guessed it by now. So the imaginary component, let's say we have 1 over 6 minus 7 over 6i. Now the imaginary component would be this part over here, which is negative 7 over 6. And you realize that these are real numbers, they are never complex numbers. So these are all elements of real. So it's not to be confused with the actual complex number z. Now for z conjugate, it's essentially equal to the same real component and the negative of the imaginary component. So z conjugate is equal to x minus iy. Right, so for example, if let's say z is equal to 1 minus 3i, the conjugate of z would be equal to 1 plus 3i. Now you realize in the previous slide that for the denominator over here, you have to multiply it by its own conjugate in order to make the denominator real, and it works 100% of the time. So let's say we have z times z conjugate, right, using only unknown variables. So that's x plus iy times x minus iy. And we're going to show that it's a real number 100% of the time. So let's start with the real component. So that's x squared minus I squared y squared. And now the complex components. So that's plus iyx, and over here we have minus iyx. So just the complex component cancels out with each other, and you have x squared plus y squared. right? And since x and y are both real numbers, x squared plus y squared, it's also a real number.